Hello everyone. This is Natasha here from the Nextwork team, and today we are going to be doing a project on building a RAG API with FastAPI together. Today, we're going to build your very first AI API. We're going to use Python and FastAPI to answer questions with your own files. That's pretty much RAG in a nutshell. So there's no experience needed. Let's jump in straight away. Now, I know the difficulty says mildly spicy, and that's because this project is project number 1 of a 4-project series on DevOps and AI. It's going to be a lot of fun. I think this project is where, we kind of go straight into the AI side of things with creating RAG and actually testing out our own RAG API. And look, we're going to go through this step by step. But I think the concepts might take a little bit of time to understand if you're completely new to it. So give yourself the full 60 minutes, maybe even buffer an extra 30 minutes to slow down with some of the concepts if you're new to APIs too. And we're going to be talking about this 4-project series now. Okay, so have you ever wondered how companies like OpenAI, Anthropic, and Cohere build AI-powered APIs that developers can integrate into their applications? The answer is modern web frameworks like FastAPI, combined with RAG, which stands for Retrieval Augmented Generation, to create intelligent APIs. And these intelligent APIs can answer questions based on your own knowledge base. So basically, how can we create a chatbot that's super knowledgeable about us? And FastAPI, you might be familiar with this, and if you're not, that's totally okay. It's pretty much a framework for building APIs. Let's maybe even peel it back another layer and talk about what are APIs. You can ask here and you can say, hey, what are APIs? Let's have a go. Cool. So an API stands for an application programming interface. And whoa, hey, take me back up. And an API is basically a set of rules and definitions that let different software applications communicate with each other. I think the simplest way to explain an API to someone else is to just say, how can 2 apps talk to each other? That communication method is most likely an API, where one application could be saying hi, software B, can you please tell me what is the weather today? Okay, and software B is a weather app. So software B receives the request via their API. And software B, the weather app, says, the weather right now is 19 degrees, it's cloudy. Sends that back to software A, via the API. So an API is pretty much a bridge or a communication method between 2 applications. And a RAG API is basically an API where basically the software that's maybe answering questions is extremely knowledgeable about a very specific knowledge base because you are training this specific API on all of your knowledge. Now, a knowledge base is actually a very simple concept. It basically is just a folder of a lot of your own documents, of a lot of your documentation. So if you wanted to build a RAG API on yourself, you'd be loading this folder up with maybe documents about your favorite movies, or how you notes that you've written from meetings in the past, or maybe even data related to your favorite books, or just things about yourself. And now this API will be very, very knowledgeable about you. So that is, the AI API that we're building in a nutshell. But, this is project 1 of a 4-project DevOps and AI series, where you're building that working RAG API that can answer questions by searching through your documents and so much more. Okay? The focus is on building that API in this foundational project that sets the scene, but there's a lot more coming our way, okay? So project 2 of this series is going to show you how to containerize your API with Docker so it works identically anywhere. Project 3 adds automation with GitHub Actions so your API can rebuild and redeploy automatically if the data in your knowledge base changes. Project 4 adds monitoring and dashboards, which will help you spot and fix issues automatically. So over these 4 projects, you're going to learn some essential skills to keep your API fast, reliable, and production ready so you can ship some real solutions, not just proof of concepts. I'm very, very excited to be, doing this foundational piece with you because building a RAG API is so much fun. Okay, this API is going to answer questions by searching through your knowledge base. It's going to use AI to generate some accurate answers. And then you're also going to get automatic interactive API documentation with Swagger UI. And overall, the tools that we're going to be using today are the same tools that professional developers use to build and test their APIs too. All right. And this is a little diagram on how that RAG API is going to work. It's going to start here. You're going to ask a question. For example, you might ask, you could ask, what is my favorite food? And then you send that over to your API server, which you're going to pretty much write some code in there so that it knows how to respond to questions like, what is my favorite food? And your API is going to go into Chroma, which is basically the database that stores all of your knowledge. And it's going to search through that knowledge base to say, all right, do we have any documents about, what is this person's favorite food? Once it has or finds that document, it's going to push that through the next part of your API definition, which is going to pass it to Ollama, which is basically our gateway to an LLM. And it's going to give that document to the LLM and say, all right, here's a chunk of data related to that question. Can you please just kind of go through all of these different pieces of data and piece together a coherent answer? So Ollama is going to be responsible for basically translating all of these raw pieces of relevant documents into a sentence response. So it goes, all right, the answer is, your favorite food is fried rice, but you also love mac and cheese, which you enjoy making on like Saturdays and Sundays. Okay, a super personalized answer if all of that information was in the knowledge base. But let's say Ollama generates that, it passes that answer back to your API server, which is then going to just pass that back to you. So again, you might notice, this is exactly how two things are going to be communicating with each other. You're going to be asking a question through your own terminal, and that system is going to basically send an API request over to your API server, which is going to handle that request and pass the response back to you over here. All right. So we've got, a little bit of an explanation on FastAPI and RAG. We have just talked about what they mean. So we'll skip over this a little bit. All right, and let's talk about what we're here to do today. Let's get into it. So in this project, we will demonstrate. What are we demonstrating? Do you remember? So we will demonstrate how to build a RAG API from scratch. We're doing this project to learn maybe how RAG works, how to use Ollama maybe, which you might have seen that little preview in the diagram, but it is going to be that gateway into the LLMs that are going to be translating documents and turning them into useful information. How to use Ollama, how to build an API and run it locally. All right, cool. So, if you're up for a bit of challenge, let's quiz ourselves on the key concepts up ahead in this project. Oh my goodness, I'm feeling nervous. It's always a bit nerve-wracking to answer a quiz on a project you haven't even done yet, but you know what? I believe in active learning. And sometimes even if you don't know the answers, just have a go. Just have a go. Actually, getting things wrong is a great way to wake you up and make you remember the information. So, first question. Which tool is responsible for running the FastAPI application and listening for incoming HTTP requests? So this is a very API-related question. Let's say, is it Pip, Unicorn, Chroma, or Ollama? All right. Well, In our diagram just now, we have seen that Chroma is like a database, so it's responsible for storing all of the information that we've got, while Ollama is responsible for being like the gateway to the LLM that's responsible for translating our documents and our information. So let's strike those two off. It's not really responsible for running an API application. But which one could be it? Are you familiar with pip or unicorn? If you're not, that's totally fine. I'll give you a hint that you typically use pip to install dependencies in a Python project. So if you are, running a Python project and there are dependencies, which are basically software packages that you need to install for your project to run, you could use pip as your kind of like your package manager to install those dependencies. Does it sound like something for running an API application? Maybe not. So let's select Unicorn and have a go. Hey, all right. So Unicorn is an ASGI server that runs FastAPI applications, handling incoming HTTP requests and routing them to the correct API endpoints. Now, ASGI server, I am not a fan of acronyms that get dumped without explanation. So let's ask, what is an ASGI server? Please be concise. Okay. Ooh, all right. So an ASGI server is a web server, and it implements a very specific specification for Python. It's designed to handle asynchronous web requests. Okay, so it's a specific kind of web server that basically implements or follows a certain standard for how Python web servers should work. Cool. But I think the more important thing for us to know is we're using it to run our actual FastAPI application. Cool. So how does RAG enhance the accuracy of AI answers in this project? Is it A, by increasing the size of the AI model's training data? Is it B, by enabling the AI model to generate answers without any external context? Is it C, by allowing the AI model to learn new information in real time from the internet? Or is it D, by first searching through specific documents for relevant information and then using that information to generate answers? Ooh! What do you think, everyone? Well, we've been talking about RAG for a little bit now. Some keywords we talked about. It should be like an expert on you. It should also be ingesting some documents that you upload yourself, and it should create some personalized answers. Which option do you think kind of reflects those goals or those themes? Now, gotta say, D sounds pretty specific. It searched through specific documents for relevant information and then using that information to generate answers. All right, let's check that. All right, so D is correct. It works by retrieving relevant information from a knowledge base, like K8.txt. Oh, that's a spoiler for the document we're about to create. And it augments the AI model's generation with this context. All right, question 3. What is a Python virtual environment used in this project? Oh, why is Python virtual environment used in this project? Is it A, to isolate project dependencies and prevent conflicts with other Python projects? Is it B, to convert text documents into numerical embeddings? C, to speed up the execution of Python code? Or D, to provide an interactive documentation interface for the API? Why is a Python virtual environment used in this project? I think the definition of a virtual environment, if you're aware of it, is a big giveaway for which answer is the correct one, because the definition is definitely in the reason why. Okay, we can talk about these 3. So converting text documents into numerical embeddings, the role for that is a specific part of a RAG system, and it's not something that requires a Python virtual environment. To speed up the execution of Python code, that could be a good guess. But do you need a virtual environment to execute Python code? Don't think so. You might need a Python interpreter. but not a Python virtual environment. D, to provide an interactive documentation interface for the API, there is a specific tool we're actually using later on in this project as documentation for the API. In fact, we name dropped the tool. Do you remember this? We name dropped it here. Does that look like Python virtual environment to you? Probably not. So it looks like A is going to be our lucky guess. And looks like it is. So a virtual environment in Python creates an isolated space for a project's Python packages, making sure that different projects can use different versions of libraries without interfering with each other. It's a bit wordy, I gotta say. But to simplify it a little bit, a virtual environment is pretty much like making sure that if you've got a lot of different Python projects on your computer and all of them might need a different version of the same tool, you can almost set up dividers so that you're like, okay, this specific project, you can use version A of this tool, or like this dependency or this package, and this project, you can use this other specific version of the same tool. Now, if virtual environments didn't exist, trying to manage the versions so that every single project you want to use is working will be very, very hard. Okay, typically if you are running a specific version of a package, that specific version is what you're running for every single project. So it becomes very tricky if you didn't have virtual environments to manage these different versions. All right, question 4. What is the function of Chroma in the RAG API built in this project? Ooh, we did talk about Chroma being our database. So is it A? It manages the asynchronous server gateway interface. ASGI. Remember, we came across ASGI earlier. Was it Chroma where ASGI was introduced? No. When was Chroma introduced? Unicorn, when we were talking about unicorn. Well, B, it serves as the web framework for defining API endpoints. Oh, there was another tool we looked at that was the framework, but was it called Chroma? It was FastAPI. C, it is a local AI model that generates human-like text responses. Remember where in our diagram, where are we generating the human-like text responses? Is it Chroma? Ollama. And D, it acts as a vector database to store and semantically search numerical representations or embeddings of text. That's our lucky guess, isn't it? Well done. So I think you might remember that there was a guess just now around what is the point of a Python virtual environment, and one of the options was about creating and storing embeddings. And now we see, Chroma is the other tool that actually does that. It's cool to see some of these answers kind of like blending with each other. Yeah, Jinx. What's the primary purpose of Ollama? We were talking about how it runs LLMs locally on our machine. It's that gateway. You should know now, what are we using to build the web API endpoints? FastAPI. What are we using to manage Python dependencies? Python virtual environments. What are we using to store document embeddings for semantic search? Chroma. But in this case, Ollama is used to run those LLMs locally on our machine. Last question. What is the main advantage of FastAPI's automatic documentation feature, Swagger UI? Ooh, does it encrypt the data between the client and the API? Does Swagger UI allow for real-time updates to the knowledge base? Does Swagger UI automatically optimize the API's performance? It's a documentation feature team. So does it provide an interactive browser-based interface to explore and test the API endpoints without manual coding? All right, team. Let's pick D because, yes, that's what documentation's all about, giving you an interactive browser-based interface. Shout out to all the tools out there that have very handy documentation features. One of them being DBT, which we actually did a project on, the DBT MCP, where we got to explore its documentation too. All right, thanks for doing this quiz with me. That was a fun, I think, 10 minutes to warm up for this project. And let's go ahead and take on the challenge of actually going and building this RAG API. I think that warm-up was great for kind of almost like having to answer again and again exactly what every part of this system is used for. Ollama, Chroma, FastAPI, Python virtual environment. Have I missed anything? I don't think so. And now let's get hands-on, all right? We're going to set up our environment first. We're going to set up the core tools we'll need for this project, which are Python and Ollama. Python is the programming language that we're using to build the API, and Ollama runs those AI models locally on your machine. So let's install them first. To build a RAG API, we're going to need both tools to be running for sure. Okay, so in this step, we're going to just make sure Python is installed, install Ollama, and pull the Tiny Llama model. Isn't that such a cool name? I love that name. Tiny Llama. Okay, so in this step, I'm setting up Python and Ollama. Python is the programming language. We're using to build our RAG API. Ollama is the tool that helps us with installing and accessing LLMs locally. We need these tools because our RAG API needs both equally. We need Python for the API code to work, and we need LLMs in order to process documents in our knowledge base. Oh, I would say in order to translate or transform the raw data in our knowledge base into personalized responses, I would say into personalized responses. All done, well done. So Python is the programming language we're using to build our API. Let's check if it's already installed on your system. If not, we can install it. So we're going to go ahead and just open our computer's terminal. I'm going to be following the instructions for Mac, but we definitely have all the instructions for Windows too. Feel free to use this. And if you have any feedback for the Windows instructions, please know that we are always working to improve them. And you can always comment in this YouTube video, or you can join the Nixer community and tell us there. We will update these instructions. Awesome. So we're going to press Command Space, and we're going to search for terminal to open up our terminal. Okay, now that we've got that in front of us, can you see it? Maybe not. Can you see it? Ooh, maybe not. Hey. Let's go and open this up. Nice. All right, I've got my terminal open now, and I'm just going to zoom in so we can all see this. I have very bad eyesight. So whenever someone is screen sharing, I'm always like, can you please zoom in? All right. So now that we've opened up our terminal, let's go ahead and just run this command to check that you've got Python installed. Now, luckily for every Mac user, Python should already be installed because Mac definitely needs it for that operating system to run anyway. But you can definitely refer to the Windows instructions as well to check if you've got Python installed here. Now, if you don't have it installed, don't worry. The instructions for installing it are all here. And in fact, we even help you with checking that you've got it installed properly at the end of these installation steps. Hey, but if you see a version number like me, Python is installed and ready to use. Okay, next up, we'll install Ollama, which is a tool that lets us run the large language models locally on our computer. And so instead of sending requests to cloud services like OpenAI or Anthropic, which is going to cost us a bit of money, Ollama runs the AI model directly on your machine, so there are no costs involved with using Ollama today. This gives you complete privacy, there's going to be no API costs, and you get the ability to use them offline. So it's very, very handy, although I have to tell you, Ollama, you do need at least like 600 megabytes of space on your computer. I would safely say, like, to be safe, have at least a gig of space on your computer to run this model. Okay, so let's check if Ollama's already installed. You might be an onto it cookie and you might already have it. Okay, it says we could not connect to a running Ollama instance. Client version is 0.13.1. So, okay, it looks like I do have Ollama. But if you see command not found, you can install it for your operating system very easily too. Here, you can, if you're on Mac, download it with Homebrew. It's so easy with Homebrew. Just check if you've already got Homebrew on you. Okay, I've got Homebrew. And if you're new to Homebrew, it's pretty much a package management system that makes it very, very easy to download software packages like Ollama. If you don't have it, I would highly recommend that we install Homebrew first. Here's the link for it. Otherwise, if you can see that you've got a Homebrew version going, let's install Ollama now, and here's the instructions for it. Now, Homebrew is very Mac specific, so if you're using a Windows today, make sure to follow the Windows instructions, which is going to help you download Ollama from scratch too. Okay, so here's a command for installing Ollama, and let's go. I'm gonna use Homebrew for this, shout out. All right, you should see the message Ollama was successfully installed at the end of your terminal output. But here we go with installing it. Oh, I should not block your view, should I? Here you go. All right, let's go ahead and install Ollama, team. I'm excited. Oh, and it says, it seems the app source applications ollama.app is not there. That's a great reminder. So Ollama has two different parts to it. There's a tool that you install locally, but there's also an app that you'd want to install as well, and those two connect together. Think of the app as like an interface for chatting, but you need to install this terminal tool so that you can even pull these large language models in the first place. So you need them hand in hand in order to even open Ollama. Totally forgot about this, which is on me, team, but the link for that is actually in the Windows tab too. It's just it's just ollama.com/download. So let's go and visit that together, shall we? And I'm gonna open in a new tab the Ollama website. Oh, this is not the right website. My bad. Ollama.com/download. Here we go, and you can download from Mac OS, which is what we're gonna do here, or Linux or Windows, depending on your operating system. All right, so let's click on download from Mac OS. All right, I think it's downloading. It is downloading, that was fast, okay. Here we go. All right, Ollama, let's open you up. I'm excited. Oh, this is so cool. Look at that little, I see you little, oh, I just realized you can't see this. I see you little drawing, but we're gonna drag Ollama into our applications folder. Okay. And once it's up and running in our applications folder, we should be able to find it right here. There we go. I see you, Ollama. That's so cute. It's such a cute little app icon. So we've got Ollama open here. Let's open it up here. Okay, so with Ollama open, we can double click on that. Oh, and we can also just double check that Ollama's installed again. So you can go ahead and check for your, not your brew version, but your Ollama version one more time. And just make sure you've got a version number now. I think I'm just going to rerun that installation command as well, because it ended with an error message just now. And let's see if it still ends in that error message now that we've installed that app. No, it doesn't. All right. So it says Ollama app was successfully upgraded. It says upgraded for me because I did already have Ollama in my computer. But luckily, we've been able to prove that once you just download the app, you won't be seeing this little error message. Okay. But very good to see that we've got Ollama open here. And if you run Ollama version, you should be able to see that version number. Okay. Happy days. Let's move on into checking if Ollama is currently running. So once it's installed, we got to make sure it's actually up and running. So let's go ahead and run this curl localhost 11434. And it says couldn't connect. Okay, so we don't see the words Ollama is running. That's okay. It purely tells us that we're gonna need to maybe just run Ollama. Easy dubs. All right, so let's start it up and run this command for opening Ollama. Boom. You should see the Ollama icon appear in your menu bar. All right, I don't see it appear in my menu bar, but we do see this funny little thing that says, hey, Ollama is an app from the internet. Are you sure you want to download it? All right, looks like our computer's getting some stranger danger, but Ollama is definitely a safe app to open up. So let's just click open, okay? And again, it's gonna try install a command line tool because we're gonna be maybe pulling new LLMs and testing them in the terminal. It makes sense to have a command line tool for that. So, I'm just gonna put in my Touch ID to allow that. And welcome Ollama. This is the interface that we were just talking about. This is like a very handy chat interface that lets you, I guess, use the models that you pull with Ollama very easily. But you don't need to use this interface to chat. Again, you can just use your terminal. So we can close this, okay? And we can now again run that same command using curl to test that Ollama is responding. So let's go curl. And there you go, Ollama is running. Well done. You can even see in your menu bar our beautiful Ollama icon. Oh, am I blocking your view? Oh. Whoa, look at me just fly across the screen. But look at that, can you see? Oh. There you go. I'll see if I can actually. This is like parkour, guys. Screen parkour. There you go. You can even see this little Ollama icon up top, which helps you confirm that Ollama is running. Now that we've got Ollama running, okay, we've got the main tool that's going to help us with pulling these LLMs. And the model we're going to be pulling today is called Tiny Llama. So let's first check if you happen to already have Tiny Llama. Unlikely, but it's always worthwhile checking if you've already got something before you put in the effort to install it. So you might be wondering, hey, what is the Tiny Llama model? Why are we using Tiny Llama? Great question. Okay. And in the meantime, I might just run this Ollama list command in my terminal. Okay, over here. And as you can see, Ollama list comes back with 0 models. Oops. Well, we only just installed Ollama, or we only just reinstalled it. So looks like we don't have the Tiny Llama model, and we're just gonna have to pull that. So pulling it basically means downloading an AI model or an LLM. Oops, wrong tab. So in your terminal, you can just run the command Ollama pull tinyllama to start pulling it. Now, downloading an LLM can take a bit of time. As you can see, I'm only 7% of the way through. It can take about a minute or more to finish doing that. For some people, if it's your very first time pulling an LLM, it could take even up to 5 minutes. Have some patience. That's the reason why we've even got this question. We've got some entertainment in the meantime. All right. So Ollama is a great kind of gateway to open source models. So every model that you pull with Ollama is open source, and tinyllama is a compact open source LLM. It's pre-trained on a massive data set of 1 trillion tokens, and it's designed to be efficient and perform well in various natural language processing tasks, even outperforming some similar sized models. Good to know. Now, it's just useful for applications in resource-constrained environments like mobile devices and for exploring new ideas and language modeling. I feel like this response gets pretty detailed. Mad respect to that, but the simple answer on why we're using a model like tinyllama instead of let's say an OpenAI model today is 1, tinyllama's open source. It doesn't cost money to use this LLM. 2, it is one of the smaller models out there. It is 600 megabytes to install compared to some of the other models, which are probably 2 gigs or more. So it's going to be faster and it takes up less space in your computer. It still performs pretty well. So for the task that we've got today, it still does a pretty good job of, for example, translating the knowledge base document into a concise answer. So I think it is a great choice for this project. If you have other projects in mind or LLMs in mind, you can actually search up Ollama LLMs to see all the different kinds of models that you can use. Also, you can actually see OpenAI's open weight models here. That's cool. And Quen, over here. So you can explore all of these different open source tools. Awesome. All right. Let's get back into the terminal. I'd imagine it's almost done. Oh, not yet. 61%. That's okay. We're just going to wait for success to appear at the end of this. And yeah, later on when we run some Ollama commands, it's just going to use this model to answer our questions. The model stays on our computer. We're literally downloading it, so you only need to download it once. This is a great time to sip on some tea, isn't it? We're almost done though. Hey, come back. All right, 80%. Let's do a quick preview of our steps up ahead while we wait. Okay, so right after we pull tinyllama, we're gonna run a quick test. So there is a command we can run called Ollama run tinyllama, and once you run it, it kind of turns your terminal into a chat interface, and that's where we can just ask a question. What is Kubernetes? Oh, cool. Do you know what Kubernetes is, actually, on that note? If you're new to the concept of Kubernetes, let's actually just spend a cheeky minute on what is Kubernetes. Please be concise. Okay, so Kubernetes is an open source system for automating deployment, scaling, and the management of containerized applications. It groups containers that make up an application into logical units for easy management and discovery. Think of it as an operating system for your data center. Instead of managing individual servers, you manage a cluster of machines, and Kubernetes handles where and how your application runs across those machines, ensuring they're always available and performing well. Cool, okay. So This could be actually a pretty in-depth answer for anyone that is also new to the concept of containers or containerized applications. We're going to go into this a lot more detail in our next project in the series. But a little preview for you is that a containerized application is basically a package that puts together your application code and all of the dependencies that it needs to run. So in this case, in the next project, we're going to package together the code for our API and also all the dependencies you need for that API to run. What are some of the dependencies? You need Ollama, you will need Chroma, you will need Python. There's going to be a few dependencies that any computer that wants to run our API is going to need. But if they are just running the container itself, this entire application that contains those dependencies, it won't need to separately install those dependencies in order to run your RAG API. That's why containers are so useful for engineers to beat this problem called the "it works on my machine" problem, basically meaning that you can build like an awesome tool, but it could only just work on your machine and not work on someone else's that doesn't have all of the dependencies that you had to go through the pain of installing for it to work. Kubernetes is a system that you'd use to actually manage all of these containers at a large scale. Say you can actually break up your application into multiple different parts, and all of those different parts has their own dependencies and can be run within their own package. So Kubernetes is a great way for you to orchestrate that group of containers that together, when you run them together, forms like a very stable application that could be bigger than a micro application. So that's why Kubernetes is often associated with, I would say, larger applications that aren't just, like a simple API like what we're doing. Kubernetes is often the solution for much larger applications that truly needs like multiple different packages. So let's check on our terminal. I think it's installed now. Very nice. And let's go ahead and run our tiny llama. Are you excited? I'm excited. Let's go ahead and run tiny llama. Ooh. Let's go and split up our little windows. This is looking a little chaotic, isn't it? Thanks for bearing with me, team. Ooh. This is looking okay, team. I hope it's okay. All right, so let's go ahead and run Ollama, run tiny llama. Yo, it's taking its time to run this tiny llama, isn't it? But it is our first time running tiny llama, which could be the reason why it's taking a little bit more time to run it. That's okay. Yo, look. So now it says send a message. Do you see how your terminal is now kind of a chat interface? Let's go and ask, what is Kubernetes? This always makes me laugh. We've asked the question, what is Kubernetes? And we get the answer that Kubernetes is a traditional Armenian dessert usually made during the winter months and includes honey, dried fruits, nuts, and spices such as cinnamon and nutmeg. Now, the Kubernetes we know is something very, very different to a traditional Armenian dessert, although this does sound extremely delicious. But why might the answer be so off topic? Well, small models like Tiny Llama, although it is trained on like 1 trillion tokens, it doesn't guarantee that it's trained on every single topic in the world, especially technical topics. So they can start to generate fictional explanations or irrelevant things to what you might expect from asking, what is Kubernetes? So this is basically hallucination in a nutshell. It doesn't really know what to do, so it maybe breaks down Kubernetes into different little tokens, and then when it came back with an answer, it's, that answer is built off of knowledge that is completely irrelevant to the actual knowledge we're looking for. So how does RAG solve this problem? Don't forget, we're building a RAG API. So for us, RAG is going to make sure that Ollama, or Tiny Llama, is going to go and retrieve relevant information from your documents first, and then it's going to use that context to generate more accurate answers. Even if Tiny Llama doesn't know Kubernetes from its training, your RAG system can pull the correct definition from your documentation and pass it to the model as context. Okay, so let's upload a screenshot of Ollama and Tiny Llama. Perhaps we can just do this little screenshot like this and upload that into your documentation. All right, Ollama is a tool for installing and running local LLMs. We downloaded the Tiny Llama model because it is lightweight, 600 megabytes compared to 2 gigs for other models, but it still works well for this project. The model will help our RAG API by converting raw chunks of data in our knowledge base into cohesive, insightful answers. Great. Ooh, our work has been updated. Let's check it out. Whoa, look at that. It's good to see our documentation updating like this already. So our documentation looks amazing. It already has the response we gave previously about what we're doing in this project. And, it already updated now that we've given a few more details around setting up Python and Ollama. So by the end of this project, I should probably just mention that. I totally forgot to mention this just now. By the end of this project, this is going to turn into a little landing page that you can share with anyone, share with employers on work that you've done. And you can even share this on different social media channels like LinkedIn, or you can put it on your GitHub profile. You can download this as a markdown file, which makes it very, very, very compatible with a GitHub README. Okay, so now let's exit by typing /by or by pressing Ctrl D. Let's do /by. There we go. Terminal back to command mode. And we're ready for step 2. Awesome. So Python and Ollama are both ready. Now let's create your project workspace where you're going to build that RAG API. A workspace is just a folder on your computer where you're going to store all the files for your project. Your Python code, your configuration files, your data. So keeping everything in one place just makes it easier to manage your project. It's just like creating folders for your pictures. So in this step, you're going to create a project folder, create and activate your Python virtual environment, and you're going to install some Python dependencies. So in this step, we're creating a Python workspace. A virtual environment is, we didn't actually talk about this. So a virtual environment, I know we've talked about it in the quiz, but we haven't really talked about it in the project guide yet. So if you're wanting a quick refresher, what is a virtual environment? You know the magic words, please be concise. Okay, so a virtual environment is like a self-contained directory that holds a specific Python interpreter, package manager, and all the library your project needs. Think of it as an isolated workspace for each of your coding projects. A virtual environment is like an isolated workspace for each of our coding projects. We need it because it prevents package version conflicts between different projects. Excellent. It's also handy that at the end of this project, if we no longer need it, the environment folder gets deleted, which deletes all the dependencies automatically. This is much less fuss than deleting each dependency individually. Okay, so hit done, and let's go ahead and set up a folder for this project. So this is going to be our workspace, and we're going to create a folder called the Network RAG API. Let's go ahead and set that up in our desktop. So I'm going to open up my desktop in my Finder. Okay. All right, and in your desktop, we're going to create a new folder. We're going to call it Network RAG API, okay? You can also run these commands in your terminal to create the folder. I just like to use the UI just out of habit. But I realized I totally should have done that, because we should be staying in the terminal, because we're going to be creating the Python virtual environment, which you must do in your terminal. So let's go ahead and just print our working directory. You might notice that's one of the steps here. Sorry team, I feel like I've led us down a more windy path by using the UI to create the folder. Forgive me, forgive me. Let's go ahead and open this up here. Okay, so we're just going to verify that our terminal is in the correct folder. What we're going to do is use pwd. Now this is the best command if you are using terminal on your Mac, or if you're using PowerShell. And you know, the output should end with desktop and Network RAG API, but clearly that's not the output for us right now. It's just my username for the moment. So what should we run next? Do you know? All right, so the output should end with desktop Network RAG API. Another handy Linux command that we can run here now is to use cd to change our directory into the next folder. Now, if you just see your username, it means you're in the root folder for your computer or your directory. So you can just change directory into your desktop. And again, change your directory again into your new folder. Okay, so let me run pwd again, and I can see that it ends in the correct, like what we're wanting to see, which is desktop / network -rag -API. This means that we've now navigated our terminal to go inside that new folder we created, making it perfect for us to create that virtual environment now. So to create a virtual environment, we are going to run a few more commands here using Python. But I just realized we are scrolling through a few things that are very, very helpful for us to understand before we go into it. Now, a virtual environment. All right, so a virtual environment is that isolated Python environment that keeps your project's dependencies separate from your other projects. We're going to need it because without a virtual environment, installing packages for one project could break another project. And let's just keep everything contained and drama-free if you have other projects going on in your computer right now. And how do virtual environments actually work? You might find it so interesting, like how do we isolate these things? So when you create a virtual environment, Python creates a folder called v. We're going to see this folder very soon because we're going to activate an environment soon, that contains its own copy of Python and a place to install the packages. So when you activate your virtual environment, the terminal uses the version of Python and the packages from that folder instead of the system-wide Python. So in short, Virtual environments work by creating a subfolder or like a sub mini ecosystem, mini environment that contains another version of Python and all of the things that you're about to install, those packages. They're all living inside VENV. So let's set it up, and we are just going to run the command to create that virtual environment. Let's run it here. All right, Python 3 -m venv. Okay, and that creates the environment, but it doesn't activate it yet. Okay, so -m venv runs a built-in virtual environment tool, and we simply named it venv for virtual environment as well. I know, so if you did Python 3 -m venv, fabulous. It means your virtual environment is going to be called fabulous. For us, we just use the classic go-to name, which is venv itself. Okay, so in your terminal, we can now actually list the files to verify that we've created this venv folder. Seeing it validates that we created this environment. So ls lists all of the folders and files that are in your folder. So venv is in here. Okay, what great proof that this virtual environment exists. Okay, and if you want, you can actually even click into your, kind of like your Finder in your computer to double check too. So, you know, we've got nextwork-rag-api. Our virtual environment should live in here. So if you double click, there you go. Your virtual environment's right inside. Very smooth. Okay, so we're ready to go into activating it now. So activating this virtual environment is basically telling your terminal that we're now going to use the specific version of Python that is inside this virtual environment folder. So if we didn't activate our virtual environment, it basically means that all of the packages that we're about to install are going to be installed system-wide. And that's not exactly what we want. So we're going to just make sure we're activating this virtual environment. Ready? To do this, it's actually a very, very simple command again. It's source venv/bin/activate. So let's run this command. And there you go. You can tell that your virtual environment's activated if you can look at your terminal, and it starts with this prefix, venv, you know, the name of your virtual environment. And if you're curious, you can always use this little handy chat tool on top of any code block to better understand the code snippet. So if you're thinking, oh my gosh, what does source venv, you know, what does all this mean? All you gotta do is click on this little handy chat icon to chat with this piece of code. So here we can see that it activates your virtual environment. It sets up your current terminal session. Okay, cool. You might be wondering, what does source mean? What does /bin/activate mean? You know, you could be a curious one. Okay, you could have all these questions, and that's totally cool. All right, so let's have a go. Okay. So the source command executes a script that's in your current shell, meaning any changes the script makes to the environment affects your current terminal session. /bin/activate is another script within your virtual environment that modifies your shell's environment variables to use the Python interpreter and packages from that specific environment. So in short, source is a command, and it means execute this script, run this script. And the script lives inside /bin/activate, and that script basically says activate the environment, which means changing your shell, which is this terminal session, change this shell to now use the version of Python and all of the environment variables that are within this venv folder. So that's a little bit more technical detail for you today, but we've got our Python environment activated. And we're now ready to install those dependencies. Okay, so now that we've activated the environment, it's now primed for making sure any dependency you install is only going to be contained inside that folder. So we're going to be installing 4 dependencies today: FastAPI, Unicorn, Chroma DB, and Ollama, and all four of them play a very unique part in this RAG API we're building. Let's go ahead and run the command for installing them first, and then we're going to talk a little bit about what they do and the part they play. The package installer we're using is pip. This one came up in our quiz, but it is responsible for downloading those packages from this app store called the Python Package Index. And it just makes sure that we're installing them into the virtual environment we activated. Oh, look, think of it like an app store. Okay, so you should see VENV over here. And let's verify pip is actually just working inside your virtual environment before you start. All right, pip version, we got a version number. We're good to go. And we're gonna see, a path pointing to your VENV folder. Okay, like this. That is actually very true. And once you've got that proof, it tells us basically that everything we're about to install is gonna go into this virtual environment. Okay, just in case you can, you're looking for it, look for the reference VENV in the middle of this path. So let's go and now just install those packages in here. So pip install FastAPI, Unicorn, Chroma DB, Ollama. Okay, so while that's installing, I'm just going to expand this so we're not distracted by all of those terminal updates or updates in our terminal. And let's have a quick look at the dependencies that we're installing. So dependencies are the packages that we need for our project to run. And FastAPI is that framework for building APIs. You might be wondering, what is a web framework? So, what is a web framework? How does it help us with building an API? Be concise. Our favorite words. And you've also got Unicorn, which is the web server. From the quiz, it's called the ASGI server. But it's just there to run your API. You've got Chroma DB, the database for storing your data. And then Ollama, which is that Python library to interact with Ollama itself, the AI model server. Okay, so if you're wondering, what does FastAPI do? What does it mean that it's a web framework? So a web framework is a collection of libraries and tools that gives you a standardized way to build web apps and APIs. It offers a structure and common functionalities, so you don't have to write everything from scratch. So for building an API, a web framework like FastAPI helps you or has certain built-in features that makes it easy for you to do things like define an API endpoint. We're going to be defining an endpoint very soon, but basically when you're creating an API, there are a lot of different things you need to manage, and one of them is called endpoints. And endpoints are basically what are the different things a user can do with this API, and how are they going to access that functionality. And if you're using FastAPI, they have basically the structure for you to be able to set up endpoints in a much faster way, where you're almost filling in a template. And once you fill in the template, FastAPI already has a lot of pre-written code for turning your template, or what you fill in, into a working endpoint. And the template doesn't just stop at API endpoints. It can handle different types of requests. It manages the logic for how your API responds to those requests. This definitely streamlines the development process and ensures consistency. Just like how, if you're talking with AI, it abstracts away a lot of the effort that goes into researching things yourself. If you're using a web framework like FastAPI, it abstracts away a lot of the effort that comes with writing an API, from scratch yourself. A lot of the logic that goes into how to process things, how something should run on your computer, that's taken care of for you already. So you're just, as a developer or as an engineer, just needing to really define what does your API do. Okay. So we have, I think we've installed FastAPI and all of our dependencies now. Okay, we've successfully installed everything. Great. I think we are now ready to go and move on to the next step. All right, so we've installed the 4 packages, and these packages are now available only in this virtual environment, keeping them separate from other projects. Now, you can still verify that your packages are installed by running this command called pip list. And, don't forget, we've got this handy tool for explaining every single code block. Let's run this in the meantime. Okay, so you can go and run pip list grep to easily shortcut and find all of these dependencies. And you can see that you've got a version number for each of them, which confirms that they are installed. Great work, team. And yeah, pip list displays all your packages, while grep filters the list to show only the lines that contain the dependencies we installed: FastAPI, Unicorn, ChromaDB, Ollama. So you can quickly scan and check those specific packages. Very nice. So let's upload a screenshot to show our terminal with all of our dependencies installed. And we can also answer this cheeky question about what is a virtual environment and what packages did you install? All right. Let's take that screenshot first, shall we? Screenshot. Here we go. Let's go. All right, let's add that to our documentation. And let's respond to these questions. What is a virtual environment and what packages did you install? So a virtual environment is an isolated workspace that contains the packages, dependencies, or I would say that stores the packages, dependencies we need for this project to run. We created it because it prevents any package we install to cause any errors in other Python package projects we might have on our computer. That's the entire reason for using virtual environments. It also makes removing these dependencies at the end of the project much easier. The packages we installed are FastAPI, ChromaDB, Ollama, and do you remember the last one? Unicorn. So FastAPI is the web framework that helps us with developing our API. Chroma is used for storing the embeddings, for storing and processing the embeddings in our knowledge base. All right, well done, everyone. By the way, I have just realized that document embeddings is not something that we've really talked about in depth yet. So here's a little chance for just asking what are document embeddings actually? Do you know what is the magic word I'm about to use too? What are document embeddings? Why are we using them in this project? Magic words coming now. Please be concise. So let's see. what is the response from our dear project buddy called the ask feature. And in the meantime, we're actually ready for step 3. Hey, well done. We're up to the last step of the project. What? All right. So document embeddings are numerical representations of text that capture their semantic meaning. Think of them as converting words and sentences into a language that computers can understand and process efficiently. Words take time to understand. Computers translate those words into specific like numbers or I would say numbers or a different format that makes their semantic meaning. That turns the semantic meaning of a word into a number that makes it very easy to map them, so that it becomes very easy to figure out, what kind of words make up a sentence together, what words have similar meanings, what words have very different meanings. If I'm searching for something, how can I make sure I can find similar results that don't contain the actual keywords I'm using, but could be useful to me anyway? I think the reason why, chatbots are so powerful is because they can infer a lot of meaning from the words in your prompts. And the better it is at figuring out, what you want, the better it can, generate results for you. So embeddings play a really big part in the reason why we can have accurate results when we search for things, and the reason why ChatGPT can respond in proper paragraphs that actually answer our questions. It all goes a long way into powering a lot of these AI systems that are working today. So in this project, we're going to be using document embeddings as a crucial part of RAG. They help the chatbot quickly find and retrieve relevant information from the knowledge base to answer your questions accurately. Okay, awesome. Let's head back and let's start that API. Okay, so we've talked about how API is basically a way for different programs or software to communicate with each other. And think of it like a restaurant menu. So the menu tells you what dishes are available and how to order them, but you don't really know how the kitchen prepares the food. It's simply just a tool for you to understand, information about what food is available and what you can order. So the menu in this case is like a communication bridge, without you needing to, let's say, go up and ask the chef yourself. You can use the API, or in this case, the menu instead. Gotta say, we might just update this analogy to make it even clearer afterwards. Most importantly, just think of it as a way for different programs to communicate with each other. And in this project, we're building a web API, which means it's a service that other applications can call over the internet to get answers to questions. When someone sends a question to your API, it searches your knowledge base and returns an AI-generated answer. All right, are you ready, team? Are you ready? And APIs are truly, what helps make your RAG system accessible to other applications. Instead of just you being able to use it in your terminal, building an API means that you can build a web interface that uses your API. You can now integrate things into your mobile apps, connect it to other services. You can share your API or share your functionality with other developers. What a great way to, not only build something, but also make it shareable, or make it scalable to others. And I think that's where, the AI and the DevOps kind of marry very well together. All right. In this step, you're going to create a knowledge document that's going to go into your knowledge base. You're going to create a script for embedding that document. And then you're going to create a FastAPI app, which you can then test. Okay. So in this step, we're building a RAG API. So RAG stands for Retrieval Augmented Generation, and we're creating files. I don't think that we really mentioned what files we're creating. but here's your hint. We're creating files like what is Kubernetes to build a knowledge base about technical DevOps concepts. An API endpoint is kind of an entry point or a communication method with our API. Requests go through endpoints to retrieve data from our API, or actually to retrieve data from our knowledge base. Okay, so we're going to go ahead and open up our project in Cursor, which is going to be a very helpful interface that helps us I guess see and edit our project's files very easily. Now I'm going to open up our cursor here like this. Okay, open up. Oh, it's not really snapping into shape. That's all good. There you go. And we're gonna go ahead and open a project. All right, from the welcome screen, we're gonna select that, and we're gonna select our folder, which is called Network DevOps API. And oh, Network RAG API, my bad. And we're gonna go ahead and just select open like this. And there we go. Cursor now has our project folder open. You can even see the virtual environment and the files in our virtual environment all in here. Yeah. Now, if you don't have Cursor, don't worry. You can definitely use any other IDE. VS Code is a great one. Or if you don't have an IDE in general, now's a great time to install Cursor for this project. It takes about, maybe 5 to 10 minutes at most, and we've got the steps for it over here. So we're going to go ahead and now create a knowledge document file, which is a file for your knowledge base. It is the source of information for your RAG system, and it's pretty much where your LLM is going to go to first to figure out how to answer questions. So we are going to create that file by first clicking on that new file button here, and we are going to name the file k8s.txt. Press enter. That creates the file. There we go. K8s is a common abbreviation for Kubernetes. So here's your little, random tip for the day. 8 actually just represents the letters. We've got 8 letters between Kubernetes. And so because of that, it's very common for people to shorthand Kubernetes into K8s. So in this file, we've now got our first piece of information, or first document, our own custom document that we can now fill in with information about Kubernetes. All right, so let's click inside our text file and let's put in the following content. Kubernetes Kubernetes is a container orchestration platform used to manage containers at scale. That's exactly what Kubernetes does. So later on, if Tiny Llama gets asked, hey, what is Kubernetes? It's going to know exactly what to say. It's got the correct information now. It's probably not going to say it's an Armenian dessert from here. Okay, so we're going to store this in our knowledge base, and we're going to now just press Command S or Control S to save the file. Okay, you should see that white circle disappear. It's gonna appear if it has something to save, like it's got unsaved changes. But once you press Command S, it means the changes are all saved. You've got no more unsaved changes left to go. And now, lo and behold, it's time for the embedding script. So we're going to be creating embeddings, which are the numerical representations of text that capture meaning. It's actually insane to think about how meanings can be translated into numbers. It's just so different to how our brains work that it makes me realize about, man, the way human brains and computers work really are different from a pretty foundational level. We really feel meaning, whereas in this case, we're trying to turn that meaning into numbers so that a machine can understand it. So you can think of embeddings like coordinates on a map, so that words with similar meanings are clustered together, like container and Docker and Kubernetes are probably clustered together. And other kinds of words, let's say beach, sand, sea, they could be clustered together. Love, hate, clustered together. So unrelated words are far apart. So for example, what could be far apart is like, let's say eggplant and container, or eggplant and Docker. I would imagine are like pretty far apart because their meanings or the sentences you use them in are just like totally different. So okay, so how embeddings work in RAG is if you ask a question like what is Kubernetes, the system is going to first convert your question into an embedding, a list of numbers that represents your question. And then number two, it's going to compare it to the embeddings of all the text in your knowledge base to figure out which text have the closest numbers to the embeddings of your question. And it's going to, number four, use that text as context for generating the answer. This is much more powerful than keyboard matching or keyword matching because it now understands meaning. Okay, cool. And Chroma is that database that stores these embeddings so you can search them, so you can search words by meaning. That's what a vector database does. It stores these texts as numbers and also has them almost placed in like coordinates or in a map in vectors within this database so that close words are stored closely together. It's awesome. Okay. Yeah, and really being able to store things in a vector database just means that Chroma can now search for meaning and not just exactly like matches of keywords being, for example, if you search because, it might search up any words that have the letters B-E-C-A-U-S-E in it and try to just match up the actual letters instead of the actual meaning of the word because. Okay, so what are we creating now? We're going to be creating that embeddings file that can turn k8s.txt into embeddings, into those numerical representations. So let's go ahead and create that file. If you don't see your file explorer, kind of like what I just did, you can pop it open by pressing Command B or just by pressing this little handy button on the top right corner of cursor. So here I go with clicking it to pop it open. And now let's go ahead and create that new file and name it embed.python so that we can create the script for turning text into embeddings. Okay, so we're going to paste that code into here. Excellent. And you can press Command S to save your work. Okay, I'm just going to quickly save it because I have a tendency to like not save my work. It's a bad habit. But saving it now so we can go and understand it here. Okay. So this script actually looks pretty simple, doesn't it? We've got our first line, which is on importing the Chroma library, so we can use it in the script. This first line basically creates a Chroma client that stores data permanently in a folder called DB on your computer. So persistent client means the data will be saved to your disk, so it will exist even after you close the program. Even after you close Chroma DB or like you close this project, the data should still exist. We've got collection for client, get or create collection. So we're going to create a collection called docs. And this collection is like a folder that holds your documents and all of the embeddings. And you can have multiple collections for different types of documents. In this case, we just need one because we've got a simple text file going. Okay. And with open, this next line, k8.text r, this basically opens your k8.text file and opens it in read mode. So the with statement here automatically closes the file when this line of code is done executing. And this second line of code just reads all of the content in your file, and it also stores it in a variable called text. So now text is equal, a string or, literally a piece of text that is Kubernetes is a container orchestration platform used to manage containers at scale. So that string, that text is now stored in this variable, so we can use it in the next line. That next line here, we're adding that this entire piece of text to your docs collection, and then it's gonna give it an ID called K8s, so that Chroma can now actually convert that text into embeddings the moment you add it to your collection. This ID's parameter gives each document a unique identifier, so you can actually reference what are the different documents that make up your database. And then we're going to print embeddings stored in Chroma, which basically just prints a confirmation message in your terminal to tell you and report back that this script has been run successfully. This line would not be printed if these lines did not complete running. So we're going to go ahead and just open up our terminal and run our embedding script, shall we? So we're going to go and open the terminal. How I did that just now, I just realized I did that very quickly. I like to use Command J as the command for showing and hiding your terminal. But you can also do this by clicking terminal in your menu bar and clicking new terminal. Here we go. Same thing. We're going to go ahead and just run the command for running this entire script. So it's simply Python embed.py. And we've got an error. What happened? So if you see that your script ran successfully, very good. If you see an error like me, it's probably going to say there's no module named Chroma DB, which we know is false because we definitely installed Chroma DB, didn't we? But where did we install it? Do you remember? So we installed Chroma DB in that Python virtual environment, which is the reason why we need to activate our environment and make sure we're in there before we run the script that uses Chroma DB. Again, that's the reason why virtual environments are so powerful. It just makes sure that your dependencies are contained in that folder. What we're going to have to do is make sure we're in the right subfolder, which is Network RAG API, and again, run the command for activating the virtual environment. Okay, so we're going to go ahead and just run this command. Ooh, hey. Source venv bin activate. Okay, here we go. So we've activated our virtual environment now. Let's go ahead and try run that Python script again. Okay. It's taking a little bit of time, but here we go. We can see the confirmation that our embedding is stored in Chroma. That is success. That is great success. Well done. You should be able to, press Command B if you don't have your File Explorer open in Cursor. But you should be able to find a new folder inside your project directory. Look at that. It is called DB, which stands for database. And it has a few subfolders or sub-items in there. Okay, so you'll find files like chroma.sql or SQL. and one or more folders with a long generated name like this. These contain the actual vector data and the metadata for your knowledge base. This file specifically is a SQL database where Chroma stores the references and the metadata about your documents and your embeddings. Think of it like an index in a library book. Okay, it tells Chroma where to find specific information, even though the actual content is stored somewhere. So it's like an appendix or an index. Okay, so the subfolder with that very, very long name contains the raw embedding vectors and associated data. This is where the actual numerical representations of your text are stored, ready to be searched when your RAG API receives a question. Okay, so you can go ahead and actually open this up if you'd like to have a click around. But as you can see, we don't actually have built-in tools for reading these straight away. So it's going to look a little awkward and look a little empty. But you can know that these files are now storing the actual vector embeddings of your text of this thing. Okay, very nice. Okay, so now it's time to create that FastAPI app. And cool beans. So this FastAPI app that we're about to create is basically responsible for setting up the system for you to ask a question and for that question to be broken down into embeddings, and then for those embeddings to be matched with the embeddings inside this database. And once we've got the best text that matches up with the embeddings of your questions, have those texts get passed onto the LLM to form a proper response to your question and pass the answer back to you. So all of this is going to be contained inside that app. So you can think of the app that we're building as kind of the connector of all of these different pieces of the system. So we've got some advantages for using FastAPI, like automatic documentation with Swagger UI. There's type validation, fast performance, and it's easy to learn. All of it making a great framework for us to use to build our RAG API today. Okay, so you're going to see that FastAPI has a very specific kind of look and structure to it. It's going to use Python decorators that look kind of like this to define the endpoints. And the moment you add a decorator to a function, FastAPI is bringing the framework, by automatically creating an HTTP route, validating the request data, converting responses to JSON, generating the API documentation. So now again, all of this work is abstracted away from you when you typically would need to do all of this from scratch yourself if you weren't using a framework. Why don't we go ahead and create that application now in Cursor? Go ahead and select new file in your project's root, and we're going to name that file app.py, so app.python. And we're going to press enter so that you create this file, see it in your tabs in your IDE to confirm it's been created. And please make sure that your file was created in the project's root folder. Make sure you didn't actually put it inside the DB folder, okay? So if you collapse your folder, you should still be able to see your app Python file. Otherwise, when you try to run it, it's probably going to say, hey, we can't find your Python or your application code if it's been hidden away in a subfolder. Let's go ahead and write the code that makes up your Python file. Okay, let's paste that in here. All right, double check that you've pasted everything, looks good. And here's an explanation on how this API works. So this FastAPI app creates the web server with one endpoint. Do you see this? This is the endpoint that we've got. It's called /query. When the request comes in, here's what happens. Someone sends a request to /query with a question parameter called Q. And we're gonna write a query very, very soon. We're gonna write a post request very soon. So you're gonna see that we have to define something called Q in our request. And that's where we write the question, like, what is Kubernetes? And what happens next, okay, is we're going to search the knowledge base. See, do you see how collection.query is now called? So, up here, collection is first created as a variable by using Chroma to retrieve that docs collection. Remember how the k8.txt file, or the words in this text file, is now stored in docs? By using collection, we're saying let's retrieve everything that's in docs. So when we have a request or a question like what is Kubernetes get sent to our API is going to first send that piece of text or your question to collections.query. And this basically converts your question queue. Your question is stored in the variable queue. And it's going to convert it to embeddings so that it can search for the most similar text in your knowledge base. Do you see how n results equals 1? It's just going to go search for similar results or similar embeddings or similar text that's inside docs, that's inside your collection. So it's going to return a bunch of results. So if there's matching text to your question, there's going to be a bunch of results. So context stores all of the results that match your question. And then later on, we've got the function for generating an answer. We're going to use the Tiny Llama model, the LLM that we pulled with Ollama, shout out Ollama. And the context is combined with your own question queue. So context pulled from all of the text that's relevant to your question, and your question itself over here is added here as well. And then there's a simple prompt that just says, please answer clearly and concisely. That's all we're sending to Tiny Llama. Here's some context that you need to know, retrieved from our own knowledge base. Here's the question that the person has submitted. And Tiny Llama is going to know, okay, with this context, I'm going to answer this question. And it's also given the instruction to please answer the question clearly and concisely. So once we've got the response, the LLM is going to generate that answer, and that response is going to be returned as JSON, as some data. So this is the complete RAG pattern. We're going to first retrieve the relevant information, and then we're going to augment the LLM's generation with that information. FastAPI is handling the structure in the background, which is called the HTTP layer, so that this API is accessible over the internet as a web service. Okay, and you can also read a good breakdown of the code line by line if you'd like to also dive into the details here. Okay, but at a higher level, what is an HTTP endpoint? An endpoint is a specific URL path on your API that performs, this function. So like, how do we get your API to do this? We get it to do this by going into the query endpoint. And when we write a request, it's going to be very clear that all you have to do is write /query in order for you to kind of like trigger or activate this endpoint. And post, so you see how it says app.post. So what is post? Post is a specific method that's used to send data to a server. We use post here because we're posting a question. We're sending some data to your server that's running this API. There are some very, very popular and common HTTP methods: get, post, put, and delete. So they do different things to your data. One is retrieving, one is sending data, one is updating data, and one is deleting data. For this method, for this endpoint, the post method makes sense because we're going to give some information first before we get something back. Yeah, we're going to give a question first. Okay, so how does your RAG API work, and what are its main components? So our RAG API works by sending a request, a question, to our server, and then breaking that question down into embeddings using Chroma. Chroma will then compare the embeddings of our question to the embeddings of the documents stored in our knowledge base. The results for relevant information get passed as context to Ollama, to our tiny llama LLM, alongside the original question and the prompt to answer clearly and concisely. The endpoint is query, and we built it using a post HTTP method because because we are sending data, i.e. the question to this API. All right. So that's the download or the lowdown of how your API works. Excellent. Let's move on. So once we save the file, press Command S, we're going to run the server. Off we go. Unicorn is going to be the server that actually runs this application. It's the engine that actually runs the code. FastAPI is the framework that helps us write the code or figure out how it's going to work. But Unicorn is the actual engine that runs it. So we're going to need to make sure Unicorn is installed by running Unicorn version in our terminal. Unicorn version, we've got a version number, great. And we can move on to checking the next thing, which is whether Ollama is running. Okay, and Ollama is still running. Great. So that means our LLM, Tiny Llama, will be able to handle the prompt that we give it to generate the response. So now that we've got the two key things that we need, Unicorn, Ollama, we're going to go ahead and start the FastAPI server. So we're going to say Unicorn app reload. Here it goes. All right. So this command is basically saying, hey, Unicorn server, please run our application, which is defined in the file app.python. And there should be a variable called app for the FastAPI instance. Here you go, app. The reload flag basically enables something called hot reloading, which basically means that if you update your code and you save those changes to your code, your server automatically reloads so it can run based on your updated code. So it just makes sure that whatever your server is running is reflecting the most updated version of your code in your computer. That's great practice. It's great for development. It saves you a lot of time and stress that can come from, maybe what your server is running is different to what your code is saying right now. Okay. So automatically your Unicorn is going to be running on is going to be listening on port 8000, which means your API is accessible at this address here. Port 8000 is a number that identifies the specific service. It basically just says the API is listening for data that gets sent to this port. Okay, so you should see output that looks like this. It's great if you can see, we'll watch for changes in these directories. Unicorn confirming that's running on this address. If you see a port in use error, you've got some instructions and help here for making sure that you can stop any other processes that's stopping Unicorn from running on 8000 or listening on 8000. Okay. Now let's keep this terminal window open because Unicorn is now running, and if we stop this command or if we close this terminal, Unicorn, your server that's running your app, is going to stop running too. So in order to test our RAG API, we actually need to open a new terminal over here. So we're going to open a new terminal and run the command for calling our own RAG API. So this command is over here. Copy that, paste that in your terminal, and it basically just says curl post, remember, send data to this specific port to the endpoint/query, and give the question Q, what is Kubernetes? Okay, so we're gonna go ahead and enter that. Okay, so we've got our answer here, and it says Kubernetes is also known as Kubernetes or K8s. Looks like we've still got a bit of like a funky answer here. It's a container orchestration platform used to manage containers at scale. Perfect. I think that is basically, great proof that we've been able to use the information that's in our knowledge base to influence the answer that Tiny Llama gives for a question like, what is Kubernetes? Because as you might remember, without this kind of data, if we were to just ask Tiny Llama, hey, what's Kubernetes? It's going to say Armenian dessert. So we've got a much more accurate response now. Great work for setting up your RAG API. Okay. So this is your RAG system working. Well done. And we can also have a little extension, a little bit more fun using the Swagger UI. So you might remember from the quiz and from all of this little build up and hints that Swagger UI is an awesome way for you to visualize and interact with your API beyond the terminal. So without Swagger UI, we'd just be testing our API like this. And honestly, here it might seem pretty easy, but in the larger scale, a lot of the time people might be testing their APIs and they need to remember things like exact routes, the HTTP method, the payload. Running these commands like this can take a little bit of effort if you've got a lot of endpoints to test. So being able to shorten that process using a more interactive visual way like Swagger UI is a huge plus. And the best part is it's so easy to use. It's already running actually. All you gotta do is click on the link to the exact location where your server is listening, HTTP 127.0.0.1 and 8000, and you just write /docs. And here you go. This is Swagger UI. Okay, welcome. As you can see, what it does is it shows that you're using the FastAPI framework, but more importantly, it shows you all of the endpoints that you've got. In our case, we have a very simple endpoint. We have a very simple API that only has one endpoint, but it's a post endpoint. Got that right. The endpoint's called query, and you can actually click on that, open it up, so you can try it out in a very interactive way. Instead of us having to write curl -x post, what is Kubernetes, using Q equals blah blah blah. Now we can just click on the button that says try it out over here and just type in your question, what is Kubernetes? Okay, click on execute. Loading, and you've got the answer right here. Kubernetes is a container orchestration platform used to manage containers at scale. So as you can see, it is a lot easier to do this compared to trying to write it from scratch. It even converts what you've typed into that proper curl command for you. So again, just helps with abstracting a lot of the complexity that comes with creating APIs and testing them. Awesome. So well done, your RAG API is working. You even got to see it in a very visual way using Swagger UI. And let's take a screenshot of that working RAG API in Swagger, okay? So let's go ahead and take this screenshot here. Alrighty. And let's drag this over here. Excellent. So an HTTP endpoint is, So an HTTP endpoint is a specific path where a request can I was gonna say it's a specific path where a request can send, retrieve, update, and delete data. But I feel like it doesn't capture the fact that it leads to a very specific function in our API. So I would say an HTTP endpoint is a specific path to a function in our API. In this case, /query is a specific endpoint in our RAG API that lets requests send questions and retrieve answers. Post is different from get because the post method means sending data to the endpoint, while get retrieves data from the same endpoint. A /request or a response pattern means, we didn't get to go into this one in detail, but a request response pattern is very, very simple. It simply means being able to have a communication model where you've got your client that is sending a request to a server, so we send a question, and the server processes that question and sends back a response, request, response. It just means asking a question, getting an answer. So we've got our question, we posted Q equals what is Kubernetes, and we've got the response back. So this is a very fundamental way that a lot of web APIs work. We just give a request like, hey, can you tell me about this? And then we get a response back. Here's the information you're looking for. Okay, so a request response pattern means asking a question, sending data to I guess you're asking a question or requesting data from a server, and the server processes your request to provide a response, i.e., give an answer. Excellent. So let's see that in our work, shall we? Well done. Okay, this looks good. This looks really good. So well done on completing the main steps of today's project. And of course, we've got a secret mission waiting for us to, challenge ourselves a little bit more, do that extra bit, run the extra mile so we can understand what we've learned today and learn a little bit more. So if you want to unlock your RAG API's full potential, this secret mission is for you. Your secret mission, should you choose to accept it, is to add a new endpoint called add, and it lets you dynamically add content to your knowledge base through the API. No need to manually edit files or rerunning scripts so you can add your, add new context to your knowledge base. This is going to be a lot of fun because, you've gone through that process of adding the k8s.txt file manually, but this is a way that you can now just add text through an API endpoint. So it's a powerful upgrade. Now other apps can expand your knowledge base in real time, making your RAG system even more flexible and production ready. So let's jump into the secret mission. All right. Okay, secret mission unlocked. We're gonna be creating that new endpoint called add. We're gonna use it to add content to our Chroma DB dynamically. We're gonna test the endpoint in Swagger UI yet again, and you get to showcase all of these advanced API design skills in your documentation too. So dynamic content, by the way, is content that can be added, updated, or removed while your application is running without you having to restart the entire app or manually edit your files. So instead of only being able to add content by editing your text file, and then you have to rerun your embeddings Python file again, let's just add new information straight away with an API call. Okay, so this is useful because in production systems, knowledge bases need to be updated all the time. If you're running a RAG system for, let's say, your company's knowledge base, I bet your company is producing new information every single day, or existing information needs to be updated all the time. So it's going to be a hassle if you actually need to stop your entire application, rerun some kind of embedding script in order for all of this information to be updated and uploaded into your knowledge base. So in this project extension, we are upgrading our RAG API by creating a new endpoint that makes it easy to update our knowledge base. Add will let us add new information through an API endpoint instead of uploading a new text file into our project's DB folder. It also saves us the effort of rerunning the embedding script. Okay, all done. So before we build the endpoint, we can understand the difference between GET and POST requests. And in this case, actually, we're just going to be creating a POST request again because we're sending new data. But a GET request would be if we were to retrieve data, like we wanted to retrieve data that's inside the knowledge base. That would be a very confusing, that would be a very, very confusing, I think, a very confusing request, given that we have just created a endpoint called query where we're querying the data. But the difference with that one is that there is a huge process involved with, passing all of the relevant text into an AI LLM and then getting a very formulated response back. Whereas a GET request like this is not going to manipulate data or anything. It's probably just going to retrieve something that's raw, from the database. So cool. So when you're just visiting a web page or ask for data, you're just making a simple GET request. But in this one, we are full on adding new data to our database. It's definitely a POST request. And to add a new endpoint to our API, we're going to need to open up our application file one more time. And let's add this new endpoint. This endpoint is called add. It's the POST request. And the code for running this, add request or add knowledge is already defined for us. All we got to do is make sure it's in the right place of our application file. So in your application file, make sure it is in its own new line, okay, at the bottom here. Okay, and you define it like this. Just paste it here. Oh, let me open this up fully. Okay, so we're defining the add endpoint after the query endpoint. Just make sure that when you paste it, you're not cutting off the previous endpoint in the middle or anything. Make sure you're just pasting it in a completely new section of your code. And make sure you're saving it. Don't see this little white dot. Make sure you're pressing Command S or Control S. There you go. So you're saving your work. Very nice. Okay, so If you're like me and you've already got, you've now pasted post into here, you've pasted your add endpoint into your application file. Here is a little explanation for how it actually works. All right, so this endpoint accepts a parameter called text. As you can see, it's over here. It is a string, and it basically represents the entire bit of information that you're adding or sending into your knowledge base. It's going to generate a unique ID for the document, and it's kind of like how this has a unique ID. You know, our text file has a unique ID here. It's going to use the exact same tool called UUID to generate a new one for the piece of text you're adding in here. Next, we're going to just add that piece of text into your Chroma collection, and the moment it's in your Chroma collection, it automatically gets broken down into its embeddings and then stored in the collection too. Return basically means it is going to just return to whoever sends that request a little status that says success, well done, the content is now added to the knowledge base. But there's also an exception here, which means if this fails, an error happens, the status that comes back is an error with the message that says we've got an error of type this, like syntax error maybe, or a type exception error if the type of text you send through isn't a text, but let's say you like put in a PNG, like you put a photo in there, it's probably gonna just say like, hey, look, like this isn't an acceptable file type. So I think that pretty much summarizes the new method that we've added, or the new endpoint that we've added into your API. So we're gonna save the file, and don't forget your server is running hot reloading because we used -- reload when we activated our server. If you forgot, that's totally fine. When we ran Uvicorn, we used -- reload here. And the automatically detected change is going to restart your server. So you should see a message in your terminal that says, look, it detected some changes in your file, so it's reloading. It automatically shut down your application and started it back up with all of the updates. So you can also even use, here's a little bonus like secret mission, which is called the health endpoint, which a lot of ops teams use for checking like readiness or liveness probes, which I just realized is a pretty technical question, so technical term. So what are liveness probes? Please use simple words and explain concisely. So liveness probes are a mechanism used in containerized environments like Kubernetes, and it helps us check if an application running inside a container is actually alive and healthy. If a probe fails, it just tells the system that the application is unresponsive, it's not healthy, and perhaps restarting the container is a good move. So think of it as a health check, and that's why calling it the health endpoint is so fitting. Whoa, let's go back up. Oh, I accidentally logged out. 1 second. Alrighty, I'm back with the project actually loading. So this endpoint health is a little bit advanced for what we've got, but it's just like a fun little tidbit for anyone that's interested in DevOps. A health endpoint helps us decide if the app is ready to receive traffic, and it also is an indication to the DevOps team that maybe we should be restarting the app if this health is not returning a status of okay. In our case, this endpoint is a mock one, so it is just by default returning the status okay. And I guess you could argue that if the app isn't healthy, like maybe it wouldn't even return the status okay. So if nothing's returning from this endpoint, that's a pretty big alarm bell. But otherwise, it's typical that this endpoint is a little bit more, I would say, like a little bit more advanced. That would say like check for this, check for this, check for this, and if everything is ticking, everything looks good, then return the status okay. We can definitely add this endpoint, by the way. Just add it to your application file as well. Okay, so we will need to update the top of your application file to read a model name from an environment variable with a safe default. So let's go ahead and import something called OS and import logging. We're gonna go ahead and just put that at the top here. And just as a heads up for anyone that's doing these steps are, again, not required for us to actually run our new add query or our add endpoint, but we are just adding them for anyone that's kind of interested in a bit more like DevOps extra work or like extra, I would say, flashiness. But really what this does is, you know how we've kind of hard-coded the model that we're using, the LLM Tiny Llama? What we're about to change in this file is to no longer rely on a hard-coded model name, so that you can actually alter what kind of model you want to use just through the terminal. And this is just like I would say, like, it was just a way for you to abstract away how your Ollama LLM gets determined. In the future, if you want someone to be able to easily change the LLM that they're using to generate a response, it's probably a little bit demanding to be like, oh, go into the app Python file and change this about the file, save it. Like, this is a bit of work for anyone that wants to use your API. It will be a lot easier for you to just say, like, okay, quickly run this thing in your terminal to tell your terminal to change the model you want to use to, so and so model. And my application is going to just automatically listen to the model that you chose in your terminal. So all this to say, all we got to do for our application file is, now that we've imported these two things called OS and logging, we can now automatically detect what kind of LLM our user wants to use based on what they've entered into their terminal. So this is something called logging, or configuration and logging, and we just need to add that into our application file like this. So as you can see here, the model name is just going to be retrieved from an environment variable in the user's OS, and it's defined using the variable model name. But if there's no model that's been defined, let's automatically use Tiny Llama instead. And it also just uses the Ollama generate call. It also requires an update to the Ollama generate call, which is the part over here, because we're now no longer just gonna use Tiny Llama all the time. We're gonna use whatever model name has been inputted. So let's just make sure our code reflects that too. You could copy and paste this over, but if you've got cursor, you might notice that it was already starting to suggest that you should change this to just model name, so that it automatically just grabs whatever model name's been entered in the user's environment variable. Okay, so you could try set a different model just for this run if you wish. It's probably going to require you to pull another model using Ollama, but you can definitely have a go at that. Otherwise, again, save your changes to the app Python file, and you're going to notice that you can still query. You can still query your API. Oh, if you'd like, I just realized I almost missed this as well. The reason why we have import logging is because you can also add lines for you to literally manually add add ways that your API could log requests. Logging can go a big long way for you to be able to trace the steps of, who did what with your API, what did they do, what's the data that they wanted, or if there are any errors, you can use logs to easily trace back the steps and say that, exactly at what point did things go wrong. In this case, let's add logging by going into our query endpoint and adding the log line logging.info query asked queue. And this basically adds a log into your API so that your server, okay, your server that's running it can actually start to just automatically write these logs, like output these logs as a response to requests. Now we can add this line above the return line. So let's paste logging.info query asked queue. And inside the add endpoint, there is another log line that we can add. And it just says, we can put that above the return as well. So logging.info add received new text. So the ID will be generated, and it also adds the doc ID for the UUID of that piece of that document. Okay, excellent work. So let us save our work. Again, make sure to save your app.python file. And open Swagger UI in your browser again so that you can now see your 2 new endpoints. Amazing. You've got add, which adds new knowledge, and you've also got get, which will just make sure that we're always retrieving the status okay if it's healthy, and it is, which is why it's showing the status okay. Great. What we want to see though is, okay, let's click on that post add query over here, and in the text parameter over here, let's click try it out. Enter some new text like Docker. Docker is a platform that uses containers to package applications with all their dependencies. So let's click on execute so you can see the success response that says, well done, your content's been added to your knowledge base. And don't forget, we defined that. We defined that in our app.py file. In your add endpoint, look, we say return the success message if you successfully added all of that text into your Chroma collection. So now that it's added, we've got that success message, and we can go and just test if that new content works. Let's go back into our post query, and let's ask the question, what is Docker? Let's try it out straight away. Oops, we've got an internal server error. I wonder what's happened. Undocumented internal server error. That's weird. Let's go and check out what's in our terminal. Oops, it's over here. And, okay, we've actually got an error because the word model name is not found. It basically says that it was looking for the variable model name, and because it's not found, we've actually failed, or like the API failed. And that's why there's just been an internal server error. I love how internal server actually just points to our own Unicorn server that's running this app. I'm so used to seeing the words internal server error and being like, oh, well, like that's beyond my abilities to solve this because there's something wrong with the server that's running this app. But it's so cool that when you're the one that created this app, internal server error is your server, so you can absolutely see exactly what is the problem. So for us, model name is not found. We can easily resolve this by defining the model name. And over here, don't forget, we can export the word model name tiny llama over here. So let's, I think we can, Control C to quit this, and then enter a value for model name tiny llama, and then let's reload our app straight away. Okay, great. So as you might have noticed, I had to quit my the running Unicorn server and then add that environment variable. It couldn't just reload or anything like that because it's not a change in the code. This time it's a change in the environment variable. So I had to quit my terminal first, add that new environment variable, and then run my server one more time. Okay, so it started up well. Let's go and try our request one more time. Let's execute it. Oh, we've got another internal server error. What's up? Still says model name not found. Has something happened? So my guess is if it says model name is not found, for some reason it says the model it's looking for is model name, which is a little strange because the model it should look for isn't model name. It should be looking for tiny llama. And we have passed that variable into our environment. So maybe there's something wrong with our application. And if we were to look at our application, when are we referencing model name? We reference it here in our get environment. And also we reference it when we generate our model. Oh, I'm seeing some red borders in cursor. I don't know if you can see this. And basically the red borders basically usually tell us that this is something that we need to be deleting. So you just have to press tab to accept a suggestion from cursor. And let's try and save that and see what happens next. Okay. So we're gonna go ahead and I think hot reloadings happened. So that should mean, oh yeah, it's gone and reloaded our app. Good. So it should have our tiny llama model getting used now. Let's see if removing the quote marks is all we had to do. Let's click on execute again. I wonder if this is it, guys. Okay. So let's test this out. Hey, there we go. So the answer is now updated. Docker is a containerization technology that helps developers streamline the process of developing, so on and so forth. No more internal server error. Clearly a great response for what is Docker. So that definitely proves to us that the add endpoint successfully added content into Chroma, and that content has been converted to embeddings. And when we use our query endpoint as usual, it can now find the new content and answer questions based on that too. So our knowledge base is definitely dynamic now. We can even go into our folder, actually, to try look for maybe the new data that should be in our collection. I wonder if it should be in here. I just realized that maybe it doesn't get, the new information doesn't get added to the persistent client. You know how persistent client, this DB folder basically represents data that will stay in your database even after you close this session. Maybe it doesn't get saved in here because we don't have any code that actually adds it to DB. So what if we actually added this to our persistent client? Would that make sense? Maybe our embeddings file can tell us. Collection.add documents text IDs equals K8s. But it seems like it should be here. Collection.add documents. That's cool. And then it receives a piece of text. Also assigns an ID for the document. Okay, update after a bit of thinking or digging into it. It seems like actually this UUID, this big long ID, isn't like the ID of the document or, for example, the piece of text that we've just added. This is representing the ID of the entire collection that we've stored in our Chroma database. So all of the pieces of text, their UUID is actually stored somewhere in these binary files that we can't open. But we should be able to actually query this database, which stores the mapping of all of the documents, their UUIDs, and what the embeddings are and where they've been stored. So what that means is, in a new terminal, you can actually maybe query your database. Let's see if this works. So let's see if we can just run this command, this SQL command that queries our SQL database, and it just says select the embedding ID from all of the embeddings that we've made. There we go. So as you can see, 2 embeddings were found. There was K8's, the ID for the text file, and there's also this longer ID here that starts with 465. And in our post endpoint, you can see that when we save this piece of text about Docker, the success message shows the ID is the ID of the content added to the knowledge base starts with 465. So it definitely all adds up. It shows us that our endpoint is working correctly, and the information can be retrieved from the other endpoint, the query endpoint. So this is really cool. Thanks if you stuck around and tried this extra secret mission. We also did, extra exploration to help us with really understanding what we've done today or what we're creating. You can definitely add more content if you want, add content about what is FastAPI, what is Chroma, and you can test your queries about these topics to see your expanded knowledge base in action. Okay, so let's add a screenshot of your add endpoint now. I'm gonna take the screenshot here. And it should show a successful response for the add endpoint. Okay, easy, no worries. Let's go ahead and just take that screenshot. Okay, I think I accidentally added the piece of text a second time, but you know what? My knowledge base can be extra knowledgeable about Docker. All right, let's go ahead and just upload that screenshot here. Oh gosh. Cool. I'm gonna take a screenshot now. And let's go ahead and add that into here. Okay, so what is the add endpoint for? We created the add endpoint to dynamically add new content into our database or our knowledge base. A request body is different from query parameters because, well, actually, I like the next line a bit more. Dynamic content means content that can be updated, added, deleted without needing to stop our application. In our case, because content can be added via the add endpoint, we no longer need to stop our application to add info via new text files we manually add. to our project folder. Well done. Okay, everyone. I think that takes us to the finish line for today's secret mission. You can definitely challenge yourself to, extra, like an extra extensions by checking out, extra data that you can add to your knowledge base, and also things that you can learn around comparisons for your endpoints, what this teaches you about API design, and a great recap of what we've done today in our secret mission. So you've built a production-ready RAG API. You should be so proud of yourself. And we really just did that, in this project. We set up Python and Ollama for local AI development. We've built that RAG API. We created interactive API documentation, and we tested our API with both curl and the Swagger UI. So let's do a quick recap of everything we learned in our last few questions. Services we used were Ollama, FastAPI, we used Unicorn, what else did we use today? Do you remember? The Swagger UI. We used Chroma for our database to build all this to build our RAG API. Key concepts we learned include how RAG works, how APIs work, different types of endpoints. Oh, I might just expand this so you can read this easier. Different types of endpoints and methods, and how to test your own endpoints. Great. So this project took us approximately 2.5 hours, my goodness, including demo and secret mission time. The most challenging part was, maybe it was understanding how the FastAPI framework works. Learning how it abstracts work away from engineers around routing HTTP requests, etc., generating documentation was a huge unlock. And it was most rewarding to test our extra endpoints /add to add new information into our knowledge base dynamically. Well done. Thanks for doing this project today. We did this project because we wanted to learn how APIs work and build an AI API from scratch. Ready for the next project on containerizing our API using Docker. So excited! Can't wait to get this started. So if you're ready to quiz yourself, go ahead and generate a new quiz, challenge yourself, and the great part about every single project in this series is you are taking home some amazing documentation of your work today that goes through, your thought process, things that you've done, your highlights, and you get to share this just like this. You can copy the live URL, send it to someone else, and they can open this URL and see exactly this web page on their browser and learn from what you've learned. You can also share this directly onto LinkedIn with a post already written as a kickstart for you. And you can also share it on TikTok with the Nextweek community, on Instagram, Facebook, X. You can download this as a PDF All the options are in front of you. You can even change that theme to a dark theme if you like dark theme documentation, or a fun theme, if you prefer something a bit more bright and fun. All right, everyone. Thank you so much for doing this project with me today. It was a pleasure. I can't wait to see you in parts 2 to 4 of this series, where we're going to containerize your API, we're going to automate deployments with GitHub Actions, and we're going to monitor our API with Grafana, and track errors and usage in real time. Have the best day, share your documentation with us, and see you in the next project. Bye!